if you recall from the other day, you remember doing when we did, we were like, okay, I want to build my backyard so that my dogs maximize the area, and it turned out to be a square. And it was like I had 600 feet of fencing, and it was 150, 150, 150, 150. Right? That was the gist of it. Right? This time, right, the question's a little bit different. I changed the question. Right? So typical backyard, like the house is one of the sides. Right? So the question changes now a little bit. Right? The process, the way like the two pieces that we're going to use doesn't change. But if I were to draw the picture for this scenario now, right? So if I drew like my house, it's going to be here, right? And then my backyard kind of like comes off, right? Right. So now I don't need this here because this is my house, right? So this side length, I don't, that what would have been used for the side length, right? My house can now go into the other three sides. So I can actually make it a little bit bigger, right? And go further back or something, right? So, but this, like, for me to calculate the area of this, right, it's still length times width, right? So I'm still going to use area equals length times width, right? But this time, what's the perimeter? Right? So the perimeter, right, I'm going to have like a length, and a width, right? Yeah, it's also 800. So I changed the number just to make the question more interesting too, right? But the perimeter in this question, I don't need to count the side length, right? So this time I have 2L plus W. That's different than before because before it was 2L plus 2W, right? So the rest of the question is identical. So I'm gonna plug in the fact that I have 800 feet available to me. So I'm gonna go 800 is equal to 2L plus W, right? And then I'm just going to solve for one of the variables. In this case, I'm going to solve for the width because there's less math to do if I solve for the width because I could just take this 2L and move it to the other side. So I could say W is equal to 800 minus 2L, right? And then we took that, right? And we plugged it into right there. So now the idea is like I'm trying to maximize the area, right? But I'm gonna get an algebraic expression that represents the area, just any area for this like particular backyard, right? That's L multiplied by 800. I'm gonna put in brackets minus 2L. That represents, so it doesn't, like, I'm just going to plug in a length and I could get any value of area, right? It's just like a function machine, just like if I wrote this in function machine, like function notation, I could plug in lengths and get out areas, right? I could get any area. It's not any specific area, right? What we're going to do is find one specific area by completing the square. That one specific area is the maximum, which is the most interesting, right? Because obviously if you're going to do something, you want to maximize what it is you're doing, right? So that's the interesting one. But this one here, this is just an algebraic expression that represents the area. You can plug in any length and I get an area, right? So I'm just going to do the math on this a little bit, right? So I'm going to take the L, I'm going to distribute it in, all right? And we'll do more of distribution later, like next unit. So I'm going to get 800L minus 2L squared. Right? At which point I could go, okay, A is equal to, I'm going to rearrange this so it looks a little bit nicer or something that looks more familiar to you. Right? Okay. And now I'm going to start this process. Right? Take this and move it up. Okay. So now, once I have something like this, now I can complete the square because I want to answer the question, like what's the maximum area? Anytime I see the word maximize, I'm completing the square. Right? That's the connection, right, that you make. in terms of terminology. So max / minimum, if I see these two words anywhere, complete the square. Okay. So we knew, like I see here now, with the completing the square process, the value in front of the variable squared is not 1, so I cannot actually do it the way that it sits, right? So I'm going to take that number and pull it out first, right? So A is going to equal -2, I'm going to open a square bracket, L squared plus 800, sorry, minus 400. That's step 1, right? There we see what I did. I took the 2 and I just pulled the 2 out, right? So if I were to put the 2 back in here, I'd better get this line back, right? That's how you're checking. So if I go, okay, -2L squared plus 800L, I'm good. If I put that back in, right? And I know I'm right, okay? Second step, all right, this is step 1. Step 2 is find the Z value, right? We're going to find Z. Z is equal to the B value divided by 2 squared, which was -400 divided by 2 squared, which is equal to, I should have given you guys more space. This is kind of my bad. We're squishing this in here. -200 squared, which should be equal to what? So 4,000 or 40,000. Okay. So once you have that, that's the number that you're going to add and subtract, right? So area is going to equal to -2L squared minus 400L plus 40,000 minus 40,000, right? And then we remember the first 3 numbers. Look, we find this magic number. They can combine down to this number here, right? So I'm going to get A square bracket, oh, missed the 2, -2 square bracket, and then I'm going to get L minus 200 squared minus 40, okay? Right, and then the last step is we got to put that 2 back in, because it doesn't make sense to have, if I were to read the vertex here, right? Doesn't make sense to have an area of -40,000 if I were to read the vertex, right? Doesn't make any sense. Also, the value out front isn't negative, it's still 1 there, right? So I gotta take this -2 that's sitting out front and put it back in to both things, right? But again, the idea is I'm trying to get rid of these square brackets, right? That's what we're getting rid of in this step. Because you'll notice how like all my answers don't have any square brackets in them, right? So if I were to expand that -2 in, it's going to stop. It's going to go over the square, but it's going to stop at the round bracket, right? So it's -2 L minus 200 squared plus 80, 1, 2, 3, right? At which case, at which point, sorry, you could say, okay, the vertex is 280, right? Which means the maximum area is 80,000 feet squared when the length equals 200, right? Well, if the length is equal to 200, right, then there's 400 eaten up, right? What must, or sorry, the width. Did I switch the variable by? No, we're okay. The length is 200, and what must the width be then? 400. Right?
Is it bad that I got the right answer without doing all the math?
A little bit, maybe. No, not like there is a way to like intuitively like create a table of values, right?
Yeah.
You sit there and do the areas. Where that's not going to work is in some of those like
The word ones where it's like gigantic numbers.
Yeah.
There's just so many very different options.
There's different, yeah, because you can have like there are questions where we could have, particularly with the revenue questions, like you can have 50 cents or 67 cents or stuff like that, right?
There's just so many possibilities.
You have the whole range in between, right? There's no saying that this couldn't have been.
Because at the start of this question, I wrote down 200, 200, 400.
Yeah. Like yeah. There is like you start develop, you can kind of see what the patterns are, right? But like a maximum revenue question, like when we do this next question here, hopefully there's more room down there where we can answer the question. You'll see. Does anybody have any questions?
How did we go from the 400L, the negative 400L to the negative 200L? I guess it's negative 200 there.
Yeah, okay, so when we did this, so the Z value, there's two things going on. When you find the Z value, there's two things. The first thing is like, okay, I'm going to get this number right here, right?
Yeah.
Before I square it. So after I square it, I get this, the second number. The second number appears here. Here's where 2 and 2 come from.
I see, it's just negative 400 divided by 2.
It's negative 400. Yeah, it's the B value. Sorry, is that what you're asking?
Yeah, I was just confused with how we got to it, but now I see.
It's this right there. Sorry, after I factor it out. It's this. It's the B value. So if I were to write y equals ax squared plus bx plus c, that's standard form, right? B is just the number in front of the variable with a 1 on it, right? Yeah. So that's that. There's your B. There's a 1 there, right? Now there's a shortcut that like may or may not have been shown, and if you took the 3U or whatever, like I don't know how this gets taught, but this is a process that allows us to answer questions, right? So I don't want you to get bogged down in the process. I want you to get bogged down in coming up with equations and struggling with that stuff, because that's really like that's the hard part of the question, right? It's making you think. We shouldn't get bogged down in a process that we use as a tool like that. Completing the square should be a tool in your pocket. You should be able to pull out and answer questions, right? It should not be something we get struggle on. So what I've done is I've tried to like streamline this into a process that's like 6 steps that you can just 1, 2, 3, 4, 5, 6 get the answer, right? So here you see two different things. The 2's come from after you square the numbers, right?
Yeah.
Where you add 40,000 and you subtract 40,000, right? By doing that, you haven't changed anything, because when I like if I were to do the math on that, it'd come out to 0. Okay. Now the shortcut is this little 1 here, right? There's the number 1. This is the shortcut. Okay. You just take this number and you write the variable in front of it and square it. It's basically you go like this: L minus 200 squared. And then write the minus 40,000, right? That's the completing the square. And what will happen is if we were to do this, so if I had this, if I gave you guys, and we'll do this on Monday, this is where we're going to start Monday's factory, right? L squared minus 400L plus 40,000. So if I asked you to factor that, right? This is the long, like detailed process that doesn't need to be done. I don't care about this. I care about the answer, right? I don't care about the nitty-gritty details, right? So if I were to factor this, if you remember this with the man method, I'd need 2 numbers to multiply to 40,000, right? But then I need them to add to negative 400. So what are the 2 numbers that make that work? You could sit there, this is what I'm talking about. This is stupid. Like, why are we sitting here thinking about this, right? We're wasting time, right? It's just it's it's negative 200 and negative 200. Right? When I multiply those together, I get this. Right? And then this turns into, if you remember this from any sort of factoring, this is a simple trinomial, so then I take these two factors, I write the variable in front, and then there's just two of them. So then you can just write them with an exponent of 2. Right?
And that's the same.
That's what we just wrote down. So why are we gonna like go through that and factor it and think about perfect square chart? Like, it's stupid. Just find this number. This is why we call this like a magic number. You throw the variable in front. L minus 200 squared minus 40,000, and then put the 2 out front. Done. There's two things. You got this magic number, the number before you square it, and then you've got the plus minus thing on the end. Those are the two things. The plus minus piece comes from after you square it. But this number just slides right in here, because it condenses the first three terms with that process. There are your two numbers that multiply to 40,000 and add to negative 400 right there.
Yeah, no. The minus 2 multiplying the 40,000. Is that from like the length, like the diameter, like the length? Like doing the completing the square. Like
This piece here, right?
yeah, that's right there. Is that from like the two lengths, or where did the minus 2 come from?
The minus 2 came from the very,
So two lengths.
from the very beginning, because he had two L's.
Yeah.
I suppose these could have also been, I don't know, widths. Like it just depends on how you label this, but you're gonna have two of one dimension and one of the other.
Yeah, I ended up completing it like two lengths and two widths.
Yeah, that's like, so if you do that, then you're seeing that the house isn't one of the sides, right? But a typical house is gonna have, the fence is gonna leave one edge of the house and come out and then come, but you don't need the materials for the house, obviously, right? They can go into the other three sides. Okay.
You're always going to be adding the plus minus thing onto your